Welcome to this workshop. And good morning. So in this workshop, I will going to spend 25 minutes to share with you how to build an AI agent on the blockchain and make this AI agent can receive the messengers, the natural language input from the users, from the Twitter as a client, and then analyze this message and trigger the actions which is supposed to be triggered. And so before we start, I just want to make a brief introduction of myself and my company, Chainlink. So my name is Frank, and I am a developer relation engineer from the Chainlink Labs. And the Chainlink Lab, sorry. This one. So I'm sorry, that is, okay. It's coming. So for Chainlink Labs, for those who have never heard about this company, the Chainlink is an Oracle company. We have a decentralized network of oracles. And our job is to move the data from the Web2 world, like data and computation resources, to the on-chain smart contract. So if you want to get the token price, you want to get the data from the server, you want to get the data from the database, or whatever you want to get, you just need to write a JavaScript or any code and send this request to the Chainlink, and the Chainlink can get whatever you want and do the aggregation and feed this result back to the on-chain smart contract. It will make your application as flexible as any Web2 app is today. So you can actually achieve or implement any business logic on the Web3 world. Okay, so let's start. And by the way, because time is a little bit limited, so I will not do the whole demo. This is a URL to this Gitbook, and I list all the details about how to build this AI agent and how to make it work. In this Gitbook, you can do it from the scratch, step by step. It is super easy. Actually, I think you can finish that in the 30 minutes. And if there is any hackathon, you want to use this the AI agent as your idea, and this could be your framework. You can build your own AI agent based on the framework. Okay, cool. So first question is, what is an AI agent and why we want to build an AI agent? So the AI agent comes to the Web3 world, I think mainly for the abstraction layer. So usually when we build a Web3 application and we want everyone else to come and use our Web3 application, the biggest problem and the biggest barrier is that the Web3 app is a little bit too complicated, and they need to know the wallet, they need to know the private key, they need to know how to send the transactions to the correct address, to the correct functions. And if the user do it not in correct way, I think something bad will happen. The security will be compromised. It is super risky and super difficult for the regular users. Think about the internet 20 years back. If you ask a user, the regular user, to input the IP address and construct all the HTTP requests or any protocol request by himself or herself, it is going to be a problem because no one knows how to do that. So we build the Explorer, we build some buttons, we have some text input, we have the web page to allow the users to use our app on the internet. But for the blockchain, for the Web3 app, we're still in this process. So AI agent, I think you can understand the AI agent as an assistant or a user-friendly UI, the user experience, to allow the regular user to interact with your Web3 application in a very simple way. They just need to input the natural language input, like, hey, I want to trade my token A to the token B, and you just need to type this sentence and send it from the Twitter or from the Discord or from the Telegram, and then the AI agent will understand it and to say which actions need to be triggered by your input, and then the actions will be triggered. So users don't need to know anything about the Web3. They just need to input what they want to do, and that can be achieved. And that is an abstraction layer to just abstract all the complexities provided by the Web3, provided by the blockchain. And that is what we want to build. So in order to build a AI agent, there are some tools maybe you can consider to use. And first, if you want to build an AI agent, you need to have a framework of the AI agent. And in the framework, we need three things. The first one is a client. You need to provide an interface for the users to use. Maybe you just run a Twitter account. This Twitter account can be your user interface, and the people can input from their Twitter account and tag your account and input whatever they want. And this is called a client. The second thing is LLM, the large language model. That is the brain of this AI agent. All the messages from the user should be analyzed and understood by the LLM. And the LLM will know which action need to be triggered and what to do with the user's request. And the third thing is the action or plugin. You can define some plugins or actions that can be done as a capability or functionality as your AI agent. For example, not all AI agents can handle the Web3 transactions. Just some of them can do that. So in order to define your AI agent, actually you define the functionality of this AI agent. So with these three requirements, there is a framework called ALIZA. That is a framework provided by the AI16Z, and that is an open source project, which is contributed by a lot of the individual developers. And with this framework, you can easily define the clients, define the LLM, and define the actions you want to do. And the next one is a Chainlink function. As I mentioned before, the Chainlink is an Oracle service, and based on our Oracle network, we provide a lot of the different services. And the Chainlink functions is one of the Chainlink services. The Chainlink functions, you can send a request to the DON, the decentralized Oracle network, and the decentralized Oracle network will receive that request and execute this request within its own environment. And all the nodes within this network will do the same thing. Maybe get some data from the database, or maybe do some computation, which is expensive on the blockchain. And after this script is executed, every node will get a result. And they will aggregate these results together to generate a report with their signatures. And this final report will be submitted to the on-chain smart contract. The on-chain smart contract, which is deployed by the Chainlink, will verify if this report is valid or not. If this report is valid, then this data can be consumed by the on-chain smart contract from other consumers. And that is the role of the Chainlink functions. So next important question we need to answer is, why do we need Chainlink functions in our AI agent? Because in the process, you can imagine that you use the Twitter to input some message to this AI agent. And the AI agent will have its own private key. And the agent will use its own private key to construct a transaction with a signature of this private key. And this transaction can be sent by the AI agent itself. And then the transaction will be executed on the on-chain smart contract. Why do we still need the Chainlink functions to relay the data from the database to the on-chain smart contract? Well, the thing about the whole reason we want to use the blockchain, we want to use the decentralized network to build our application, is because we want our application to be built on the network, which is a very transparent, tamper-proof, and decentralized. It is fair to everyone. And if you rely on the single point to send a transaction from the off-chain world, it could be risky, right? If something bad happens to the AI agent, if the LLM does not make the correct analysis, maybe the wrong transactions could be sent from the AI agent. So we need another layer to verify if the transaction is valid or not. So in the AI agent, we have the database to save some data, and we have some logics on the smart contract to check if the transactions from the AI agent is valid or not. And if we want to check if the transaction is valid or not, we need the data from the database. And the Chainlink functions will help you to do this, to fetch the data from the database to the on-chain smart contract in a very decentralized manner. And the whole process can be verified on the blockchain by anyone. Okay, let's see the very high-level architecture. Click that. Okay, cool. So this is the architecture we are going to build. Actually, I'm not going to build in this 20 minutes, but I list every details on the Gitebook. So we have 3 domains. So the first one in the left hand, that is the front end I mentioned. In the front end, we only need a Twitter account, and then we connect our AI agent to this Twitter account as a client. And the user can input anything they want from their Twitter to this AI agent connected Twitter account. And this natural language input can be analyzed and understood by the brain of the AI agent. That's going to be a LLM. You can use the OpenAI, or you can use the Anthropic, or maybe the Grok, anyone you like. And when this brain just see there is some specific action need to be triggered based on the input you submit, then this action will be triggered. And we have the self-defined plugin in the framework. And then this AI agent will construct a new transaction. This transaction will have all the necessary data like a smart contract address, the function name, and everything we need to send a transaction. And then the transaction will be sent to this one, the second domain, the blockchain. This the backend for the asset. And there is a smart contract called a Chainlink function consumers. And this function will have 2 main functions. This smart contract, has 2 main functions. Send request and fulfillment. So the send request will collect all the necessary data and emit an event. This event is actually a request because it will be detected by the DON here. It is a decentralized Oracle network from the Chainlink. And if there is an event emitted, the DON will detect it, and then it will say, oh, someone submit a request. And this JavaScript code or any code you want the DON to do will be sent to this DON. And the DON will run this script, maybe get data, maybe do the computation. For example, in this scenario, the DON will fetch the data from the database and to check if this record matches user input in the Twitter. And if these 2 records match, it will return the result to say, oh, good, you can just pass this request. And then the Chainlink function consumer smart contract will receive the result to see the request is valid from the user. And a new NFT will be minted to this user's address. So from the very first to the very end of the process, the user just need to submit the natural language input here, and then he or she will get an NFT on the blockchain. They don't need to install MetaMask. They don't need to know how to construct a transaction. They don't need to even click a button. And by the AI agent, they can submit their request very easily. And this will help you to just allow more users, more end users to use your application. And even more, I didn't do it in this demo, but maybe you can consider use an AA wallet. And with that, users don't need a public key. Never. They just need to submit their request. But for this use case, for the Gitebook, I still use a public key, but you can just extend it if you want. Okay. Let me go. Yeah, here I list some prerequisites and setup. You just need a Node.js, and you need to install the PNPM on your machine and get some test tokens for the Avalanche Fuji, or if you can get any tokens on some other testnets, it's okay. But this testnet should be supported by Chainlink functions because the Chainlink does not support all chains. It has a list of the supported chains. You can check that on the Chainlink official documentation. The URL is docs.chain.link, and super easy to remember. And you can check all the supported blockchains from the Chainlink. And also, because we need to use a LLM, you need a LLM, large language model API key. And the Google Gemini is free. And if you have the OpenAI or if you have a Grok, you can still use the API key from other large language model. And yeah, I will go through all the process to create this AI agent. It's super easy. And the first one, because in this scenario, we save some gift and gift secret code in our database, and we can share this secret code to the friends or to our users. And the user who knows the secret code and has a Twitter, this user can submit a sentence like, oh, please just give me the NFT to this address. My secret code is blah, blah, blah. And this message will be analyzed by the AI agent. If the data is correct, if the secret code submitted by the user matches the secret code saved in the database, the AI agent will know that is a valid result, and the chaining functions will run and call the mint function of the ERC-721 and mint NFT for this user's address. And in order to have the database, I use the Supabase. It is a light version of the Firebase. You can, if you have an AWS account, you can also use your AWS DynamoDB or any database to create a table to save 3 columns: the primary key, the gift name, and the gift code, and create a table to insert some value into this table. And what I inputted here is I have 3 gifts: the 1 month premium, $50 discount, $100 discount. And for each gift, I will have the secret code for each of them. And if the user knows this secret code, I'm really sorry about that. If the user knows the secret code of a specific gift, and the user can input this secret code and his address in the input, and this will be submitted to the AI agent. And this is where the secret code will be checked by the chaining functions, because the chaining functions need to verify if the transactions submitted by the AI agent is valid or not. So it's super easy, and create an account in any your favorite database and create a table with 3 columns: the primary key, the gift name, and the gift secret code, and that's it. And after the table is created, you need to promise this table, the records saved in this table can be accessed by the external users. Usually in the Supabase, we have the row level security, and you need to set it as a read permitted for everyone. And if you use another database, like in the DynamoDB in the AWS, you can choose this access with the IAM account and set some permission group and make sure this data can be accessed by the outside users. And after that, in the second step, we need to deploy the smart contract, this part. This smart contract will have the 2 features. The first feature is the chain link features. So this smart contract will inherit these 2. The first one is a function client. As I mentioned before in that architecture, if you want to send and receive the request and the feedback and the result from the chain link functions, you need to promise your smart contract at least has these 2 functions. The first one is a send request, this one. And you need to just tell the chain link functions what you want to do. And you can write this code in the JavaScript. I hard-coded here. This is a JavaScript code, but I set it as a string in the Solidity. You can see that I just make a HTTP request, and I give it my URL to the Supabase I just created in the last step, and I use the get method. And then I can also define how I want to handle the results from the database. I will see that use a find and to encode this result with a string data type, and then return this encoded data back to the on-chain smart contract. And this data, this source code will be executed in the environment of the Chainlink functions. The Chainlink functions consists of the multiple nodes, the Oracle node. Every Oracle node will run this script submitted by you, and then the result will be sent back to this function, the fulfill request, the second important function you need to have in the Chainlink function client smart contract. And you will get this response as a parameter, and then you can do whatever you want to this response, and to see if the response is a valid signal or invalid signal. If that is a valid signal, it will be the safe mint will be called. And that is a second smart contract we are going to inherit. Make sure this function is a NFT smart contract. The NFT can be minted within this smart contract. And then the NFT will be minted under the user's address if that secret code matches. The secret code submitted by user and the secret code saved on the database matches. Okay, so this is a smart contract that you can build, and you can implement any logics, any business logic you want to implement in the send and the fulfill functions, and you don't need to follow everything I write here, because sometimes maybe you want to add an action to transfer the token from the blockchain A to the blockchain B, or do some trade token A to the token B, or maybe do something else. You don't need to follow everything. I just want to let everyone know that how you can implement these functions and business logic with the Chainlink functions. And the next one is to register the Chainlink consumer smart contract on the Chainlink subscription. Because you want to use the service from the Chainlink, so you need to pay for that. The way to pay for that is to create a subscription under the Chainlink functions and add a balance, add some tokens, native token or link token as a balance for this subscription, and then to add your smart contract as a consumer in that subscription list. So it will make sure the Chainlink functions, the balance in the Chainlink function subscription can be consumed by the smart contract in that consumer list. Okay, after that is done, another important topic is that how we can expose the sensitive data to the Chainlink functions. Because you want Chainlink functions to get the data from the database, but the database has some permission group, and it cannot be accessed by anyone. It only can be accessed by the person who can provide API key. But this API key cannot be written on the smart contract, right? If you write an API key on a smart contract, that is transparent, and everyone else will know what is the API key. So the way to upload our API key or any other sensitive data to the Chainlink functions is to first encrypt this API key or the sensitive data with a public key from the DON, from the Chainlink functions. And then this secret will be encrypted secret. And after that, you can upload this encrypted secret to the DON or to your own server that can be accessed by the Chainlink functions. And if anyone wants to use this secret, this encrypted secret, this person should have the private keys of all the Oracle nodes in the network. So that will make your sensitive data super secure. And that is the first, the sensitive data firstly cannot be accessed by anyone. Second, if anyone gets it, this secret cannot be decrypted. Okay. We have an official script to help you to manage the script, to upload this script, and to just let the DON know where to find it. And I have all the codes within that GitHub repo. You can just go to this one, and you have this URL, so you know where to get it. Okay, after all of this is set, you can start the AI agent. Just use the npm start to start AI agent, and that is running. And you need to select the Twitter as a client for this AI agent. And when it is started, you will see from your Twitter, like AI agent starts at some time step. And then you can tag this Twitter to just input the thing. Please give me the gift on the address, blah, blah, blah. And the gift code is this one. And when this message is sent from you, it will be a memory of this AI agent. And the brain of the AI agent, LLM, will use the prompt engineering to understand what you really want to do. And if you add a prompt engineering, like if the user input something like this, you don't need to do it exactly the same thing, but just let the AI agent to know that what kind of the message will trigger which action, and that's it. And the AI agent will know when this message is sent from the Twitter, the AI agent will know, oh, the action like mint NFT should be called or get gift should be called. And it will be call the chaining functions to get data from the database to check if these two pieces of data matches or not. If that is a match, the AI agent will send a transaction and return the transaction hash ID and other details back to the Twitter, and your end user will know if that is successful or not. And next, you can check that if this request is good or not in the chaining functions UI. And finally, if that is correct, if everything is good, is valid, you will see that the NFT will mint it for your address. So the whole process is super easy for the users. They just need to type what they want to do from a social media, and the AI agent will receive this message and understand that and decide which action should be triggered. And then if the result is good, the action is triggered and the result will be good, and the user will get what they want. And except for everything I talked today, you can also just implement what you want in your own smart contract. For example, you want to do a AA wallet, you want to do a bridge, you want to do a automatic trading, you can just expose your functionality, your capabilities through the AI agent to the regular users. And then that's it. That is pretty much I want to talk today. And I will be around if you have any questions or something you want to talk with me. Please just feel free to come to me. And I'm glad if we can talk about the technologies. And thanks for your time, and thanks for your patience. Thank you.